Hello students, today we are going to discuss about the gravitational waves and their detection. In the previous lecture we started with the special theory of relativity as well as the general theory of relativity. The basic idea of these theories given by the Einstein and the notion of gravity and other things. So as we discussed, the gravity is nothing but the curvature of the space-time. Space and time are not different, but the different aspect of the same entity, same thing. We discussed this already. Now we come to the gravitational waves, a kind of radiation. So gravitational wave, just like the electromagnetic wave, it is invisible, ripple in space, and these travel at the speed of light, just like the EM waves. These waves have the property that whatever comes in their path, these waves can squeeze and stretch that thing in the different direction. So in one direction, if it can squeeze the arms or the any length, then it will stretch in other direction during their passage from that thing. Anything, these can penetrate anything. So Einstein predicted in 1916 that something happens when two bodies such as planets or stars orbit each other. So and this kind of movement could cause ripples in space. These ripples would spread out like the ripples in a pond when a stone is tossed in, and these ripples of space are called gravitational waves. You can see here two planets or two stars, you can assume these two things. So they are orbiting each other, and this phenomena, this movement of these two planets causing the ripples in space, the space time. So these ripples are the nothing but the gravitational waves, and it can travel to the through the universe. It can also reach our earth. So here I can write it down, the important thing which is the result of Einstein theory, that according to Einstein, one thing, okay, right. So according to Einstein, he gave a quadruple formula which we will discuss later, and he came to the conclusion that as we know that accelerated charge, accelerated charge will create or will generate the EM waves, electromagnetic radiation or waves. So just like the accelerated charge result in EM waves, he showed using its quadruple formula that accelerated accelerated mass, okay, will generate an gravitational waves. So this is the basic idea and the difference between the EM waves and gravitational waves, but most of the properties are same. But accelerated charges will generate EM waves and accelerated masses will generate gravitational waves. Okay, now let us see further properties of gravitational wave. So as we said that so there are three possibilities how gravitational wave can be caused, can be created. So first thing is a star explodes asymmetrically. It's also called a supernova. So explosion happens and ripples will generate, or two big stars orbit each other, just we showed that in the animation, or when two black holes orbit each other and merge. So the collision of the black holes also creates the gravitational waves. So in all these things mass is accelerated. So what happens, these type of objects, because these are all very heavy objects, and these phenomena are also this happening is very far away, so sometimes it causes very small and weak gravitational waves. So the magnitude of these gravitational radiation is very small, and it makes it very difficult to reach on the earth, and so it is very difficult to detect these gravitational waves on earth. So whether while we know from the theory that the gravitational waves exist, but practically it is very hard, it is very difficult to detect them, to measure them. So it remained a challenge for the scientists until in 2015 the scientists detected for the first time a sign of gravitational waves on the earth. So let us see how it happened. So this is known as LIGO, LIGO. Its abbreviation stands for Laser Interferometer Gravitational Wave Observatory. So these LIGO were installed and set up by the scientists many years ago, and scientists were trying to get us any detection, means any sign of gravitational waves, but in 2015 they succeeded, and the first gravitational waves were measured in 2015, and the gravitational waves which was measured on earth in 2015 was generated 1.3 billion years ago due to the merging of two black holes. But these gravitational waves traveled and reached on earth in 2015. So how did we detect them? Let us see it. So we know that the gravitational waves, when it passes through earth, it squeezes and stretches space in different directions. So LIGO can detect this squeezing and stretching, and LIGO observatory has two arms. It is based on the Michelson interferometer. What we you must be familiar with the Michelson interferometer in the optics. You must have studied it, and it is based on the light phenomena, where we used to have two arms, and laser beam is divided into two arms. Two mirrors are used and the interference happens and we get the fringes. So it is very a delicate and sensitive uh, experimental setup. So by using this kind of setup and having very large arms, two arms of having the mirrors, we can design experiment where any kind of vibration, any kind of change in length can create a change in the interference fringes, so that we can detect, we can say that this is the some kind of vibration, some kind of radiation is coming. So if we can eliminate all kind of possibilities, that pressure or magnetic field, seismic vibrations and all kind of vibration before doing the experiment, then this is the only possibility of having a gravitational wave passing through that, which is creating the change in the interference fringes. This is the experimental setup of a Michelson interferometer, where laser is the source. It is first divided into two beams by using a beam splitter, and the two mirrors are used in the two arms. The two arms are nearly 4 km long, and the whole setup is designed under the surface of Earth in a tunnel, and these are fully reflective mirrors. So two beams are reflected from the mirrors, and again they are recombined on the beam splitter, where the interference happens, and this interference is detected by a detector. So this is the setup which we already know. Then the interference pattern, so when there is exactly, means though both the arms are exactly equal, then we have the destructive interference. But any change in the one arm will create a disturbance in the two path length. So path difference, optical path difference is changed. So there is a change in the interference pattern, or when there is no light, means destructive interference was there, so we have some kind of bright and dark fringes. We say that there is a gravitational wave passing through the earth or the setup. So this is the real photograph of the same Michelson interferometer setup. This is the LIGO USA, first designed in USA, and if I zoom it, then you can see the one which we discussed just in the previous slide, that the two arms 4 km long are shown here, and this consists of two observatories initially. One is Louisiana, US, and one in Washington. Both are some distance apart. So in both the observatories in 2015, scientists got a signal of passing, or the measurement of gravitational wave passing through this setup. Here is an animation. You can see laser beam which is divided into two arms. Two arms are reflected and the interference happens. So initially they are cancelled, means destructive interference happens, but like here gravitational wave passing, so change in the arms happens, and now phase is disturbed, so we are getting a change in the signal by changing the interference pattern. Again you can see here, okay, they are not in phase initially, but after the gravitational wave coming through it, this squeezing and stretching happens, so that the effective path length is changed. This is the basic idea, and scientists were trying to achieve this, trying to find out a signal from many years, but in 2015 they got a signal. So here now I can write here. First thing is LIGO, Laser Interferometer Gravitational Wave Observatory. So this was based on Michelson interferometers uh, experimental setup, and this is what we just discussed. And one another thing is LISA, LISA, Laser Interferometer Space Antenna. This is another technique again based on the Michelson interferometer setup, but now the difference is that this LISA is much more sensitive than LIGO. For increasing the sensitivity in LIGO alone, we you know we did means we took very large arm length like 4 km, but in LISA it is billion, means million times, 6,000 600,000 600,000 times more, times 600,000 times more will be the arm length. And how will we do it? It will be done in the space, so it is called laser interferometer space antenna. So it is first kind of space based detector for the gravitational waves, and its proof of concept was already tested, and it was passed in the proof of concept, meaning miniature setup was tested, and then now it is ready to be launched in future years. So let us see what is the basic of LISA. So this is a summarized poster of this LISA, and you can see here 3 different spacecraft are shown in the our galaxy, where this is the laser beam is again used, and the total arm length is 2.5 million kilometers. This is very very long, so it makes this total LISA setup very sensitive. So even if it is difficult to find out, to measure, to detect gravitational wave on Earth by using LIGO, but at the same time LISA can detect any kind of very very weak signal also, because gravitational waves are very weak. So LISA is very sufficient to even detect very weak magnitude gravitational waves because it is based on a space. So here we will have very small disturbances or noise. So this is the proof of concept. This is called LISA Pathfinder. It was tested in 2015, where the 2 test masses were detected in the used, and again interferometer setup was used between these two in the laboratory. So you can further read this about this LISA, and because it is not yet started, and in 2000 here we have this information that in 2030 it is expected to be launched. So this is a new technology, and the basic idea we have discussed, that interferometer is the basic idea, which is very sensitive technique, which is very important science here, which is going to take place. So LIGO USA started from USA. Now it is being set up in India also. So far it has been installed in many countries worldwide, in Europe, in US, starting from USA. But now in Asia also there are many countries which have LIGO, and now in India also, since from 5 or more years, LIGO is being set up, and it will be, means, ready to be uh, started, means fully functional. It will be in the next years. So it will be very interesting about gravitational waves, about gravity. So you try to go through it from the Google, from the internet, that what is the new science going happen in future years. So in the next lecture we will start, we will have to now study about the theory, about the equations given by the Einstein, about the gravitational waves and its properties, its energy, its energy density and other things. But before that, you have to be familiar with the idea of tensors. So now most probably I will start with the tensor in the next lecture. Thank you.